Right. Something a bit different this evening. Just gonna. Colin, who's often on, he was asking about Intel Hex format to binary converter. So I thought this evening we'd quickly write one. It's not going to be a pretty program. It's going to be functional, I think, is how we describe it. But as I say, it's nice to talk. Colin, he runs a company called Quasar, does quite a lot with Sound Cafe, got various bits of his hardware, so always nice to be able to help out. It's just going to be a simple program. Takes in a, I've got it in here, it's a i86 Intel Hex file format, and we're going to squirt it out as binary format in some fashion. Put the debugging for it. Hang on. I've tried to add a chat box too, because I've realised it looks a bit odd because I can see a chat window and no one watching the streams can. Yeah, just try and write your utility. As I said, it's not going to be ideal. Yeah, I mean, it's not going to be pretty, but it'll be functional. At the end of the day, that's what you need, is something that just does the job. It's not like it's going to be released and used for hundreds and hundreds of things. Yeah. Useful to have a ret at the end of the function. So get here. Let's put a bit of debugging for him. Using just use stream reader. I write a lot of my tools in C# these days just because they are so much easier, just so quick just to do. So open our input file. Let's keep track of the line number as well, just so that's some debugging thing. Process the input file. Now, your most basic line has got to have your initial character, your 11, your size, your address, your time, checksum, so 11. Put in some very crude error handling. It's less than 11. Something's gone wrong. Characters. And so we've got enough. Gotta have some first character. First character of any line has to be colon. So if not, we will put an error saying invalid or missing. If we have got here, then we can read the bytes. So so we're going to want to get size. Like functions as these. Let's address. Address is 2 bytes. And get the type. 3, 4, 5, 6, 7. 3 byte. Right. Let's write those functions. Oh, that's bad tonight. String. So if we're reading a byte, we want first. Got 2 characters, and then convert that to it. We should be able to do that. From base, yeah. Base 16. So that should read word. Read word will be could just call read byte twice, but here all we've got to do is that. Oh, change the string. There's some plugins for the streaming software I use. I think will allow me to, quite often it misses windows. So when I flip to another window, you don't see the bits that I see. Like then I flip to debug just to see if those functions are working. But it doesn't update on the stream, so I found some, there's some plugins for this Streamlabs OBS that I'll try and configure at some point, so hopefully you can see those. But those seem to work. Read byte reads the next 2 digits. If I flick to this file, so we check this, and then read byte reads these next 2 bytes. Read words, these are direct words. Read byte reads next byte. I can't read the checksum because the checksum always comes at the end, and if there's data, then we'll need it. But we can now strip this data. So the last one we've read is type, which is 8, 7 and 8, so we want 9. Right. So we need to calculate checksum. What we'll do is we'll add int checksum. So it's not updating. This, 1 second. I'm just trying to see why you're not getting the updated stream. That's better. Right, you should now be seeing the stream again. Right, so what I was just saying is I need to keep track of the checksum. Yeah, so if we set the checksum to false, I believe checksum adds in all size, address, type bytes as well. And then what we can do, we read a byte. Add on. Bytes there, and some other word. What am I talking about? Just be that. Okay. So hopefully every time we do a read of a byte or word, it'll add it up. What handles type as data? Case there is just raw data. I'll come back to that. First thing we're going to get in the file is our linear address byte. I'm interested in the file format that Colin sent has got a slightly different interpretation from the file format I've got. When I pull up the specs, it says type 4. Have a look here. This is type 4, so we've got the colon size of the data is 0, our address 7A, type 4. The Intel docs say that the length of the data should always be 2, and that 7A should be here. The address should always be 0, and the address will come as data, but in these files it's not, so we'll put a special check in. So the docs say that the size should always be 2. That's the data we've got here, so the size is 0. I'll handle those, but we'll throw an error if there's another problem. So invalid type 4 data. So this will now become the address. It's type 2, the base address equal a read of a word. Line. Define it in. So get our base address. Once we've processed the types, last byte would be a checksum. Because there's 2's complement, what we can actually do is just read line. It's not the fastest way, but it will. Yeah. Read the data and skip. So we just pull out the string after. Here, so we just read the byte, and we then check the lowest byte in checksum 0. So if our checksum value, the lowest byte in checksum is not 0 at this point. Yeah, so if it's not 0, we'll say there's an error in the checksum this line. Let's actually start line 0 there. Right, so let's increase line number. We need somewhere to store this data. Let's have a very data chunks. We're going to store them in chunks. So I'm not a fan of it. It's a quick tool. Oh no, I'll do it properly. Really, I should separate this out into another class. Oh, maybe I will. I'll create a new class for this. I can't bring myself to write really bad code. I could make these public, but there's very, very rarely a reason to make data public. Let's use a list of bytes. If data can be public, it can just as easily be private with some excessive variables, excessive functions. Pass and base address. Lead the functions. Get data. Which should just simply return our data. We could use that for everything, but we'll let's just add byte. This add byte function. Add a byte to the list. So data.push. So add. Public int. get size, data size. And then here we want some static private data. And then a list of data chunks. So this will be our data chunks that we read out. We'll create them when we get here. Let's see if we have. Do we check it? Let's create it here. Theory could get here because the default to base address is 0. We could get here, so if that's the case, we'll add a data chunk. Let's use base address just in case. We'll add one. That's where we're going to do. Make sure we've got enough data. So we're here to set new address. We need to be able to get the current data chunk. Ways of doing that, but it'll do. We know it's going to be one because we added it above. The function for that set address offset. Yeah, so before we add data, we know what a base address is here. So if we go back to this file here, you'll see the base address would be 7A or 78000. But on this line we read 20 offset E000. So here we need to pass in E00. If we haven't got any data, we can just offset the base address. Should be possible. Maybe. I'm going to assume, should never assume, I know, address offsets increase. I don't think there's a time that these addresses would ever drop back again, so you get like E00 and then C00. If you do, yeah, it's more of a problem. Then we just have to take this out, I guess. But to increase base address. Else, we need to look at how many bytes differences. So our current offset. The difference will be between where we want, so in this case it will be an E000, minus where we currently are at, which is the size of the data. Because these are always 60. Data comes in with 16-bit data offset, I believe. So we just get difference. And oh, this is really nasty, but it's probably have better ways. But let's clear some data. So offset us. And then while size is not equal to 0. Oops. Read some data, line equals lambda substring 2. That should read the data. The only other thing we need to check is for so if we create size, so if it's here, we actually want to create a new chunk as well. Send this. Yeah, the view account's a bit odd sometimes. Don't ask me why. Debugging is always fun. I thought I'd add a chat box to the stream so people could see what type of people are typing, but I'm not sure it's working. I might have to spend some time this weekend having a good look at Streamlabs, OBS, try and improve the quality of the streams. I've got a better microphone, it's turned up. Hopefully I'll be a bit clearer. But yeah, the only other thing I need to check is for the termination of which type 1. I don't think there's any data ever in termination. I have plenty of dough moments, trust me. Yeah, as I said earlier, I should write things a lot quicker and just not worry, but I just can't bring myself to do it sometimes. Like the data chunk, I had to put it in a separate class, add functions. So, but then, hey, when I was doing Puzznic on the Sam Cafe, there was that Spanish company where they used to send code off to be analysed, and I got a very nice. I wish I'd kept a copy of that letter. They praised me on my layout and commenting and everything in my code. It's always nice. Yeah, I'm gonna have to start learning EZ80, aren't I? I feel that's gonna be another learning curve. Things like out and out zero, yeah, that's gonna catch you when you're used to doing a lot of Z80. Right. Let's see if I can add. I think I can add. There we go. I think if I do that. I think now you'll be able to see me debug. So you'll see the debug as well. So. Yeah, mix and matching, that's never going to end well. Right, so we come in, we've read the first line. It's got the right character. It's type 4, 700. It's going to come in here. It's going to create some new data chunk with the address 0. Oh, well that's good, the checksum stuff's working. We're on to line 2. Again, size 20, address E000.0. So we know we've got the data. Going to set data count to 0, so we're just offsetting the base address. So as far as we're concerned, this data chunk starts 78E0000. And then we're gonna add byte C3. So look at this file. C3 DC, so the next one should be DC. DC, seems good. It's unusual something to be working so well first time. Read that line. Wow. Just a few breakpoints in. Oh. Out of memory exception. Something didn't go well. Well, kind of everything worked first time, can you? Right. How many lines are in this file? It's 195 standard lines. Let's Oh, you get to line 3. It just keeps on going. Okay. Ah. That's when I set the address the second time. Right, so we know what data our offset is. Yeah. Maybe there. Shame not us. See that's a very you've certainly got dots appearing on your OLED. Certainly it looks like the game of life. I guess it depends, is that what you're achieving? What you wanted to achieve? Oh, of course. I want to see a nice Quasar logo on it. The problem is, I want offset users around at 20. So yeah, so here I actually need to add on base address. Minus and 16-bit. Actually, I want to see my name in lights, but you know, it's fine. I'll let you have yours. You did do it. You did design it all. Right. Let's try this again. So, one offset E020. Good. This time it says the difference is 0. Guess I still got something wrong. Cool. Can I make a personalised one when I get mine? Oh, well, we are. It seems to be processing data. So far did it get before it died? We're running quite a while. Let's put a quick time. Yeah, it's out of memory. Oh, my line number won't be valid there. Let's stick it outside the loop for a second. Line 67. Okay. Let's stick a breakpoint here where the condition is 1:67. Okay.
Every turn I take it fast. Every move cannot be surprised. Chill like you never feel like you never live like you never did before. Every moment
Oh.
will be lost. Only I can know the cost. I am fooling all the strings.
Helps if you decrease your diff loop rather than just zeros. But there's no tomorrow. Oh. Well, in theory, that's converted your files. We just need to write them out. Let's just have a look at the data chunks that are created. Yeah, in this one we've got 3 data chunks. Probably won't write out the other 2 because they're zeros, because there's just a couple extra. I think on that file you sent me, you said there was a couple of... Oh yeah, just a couple of extra ones in the end. Right, so let's just write out the data, and then it should all be working for you. Now we want to use a binary writer. Equals new binary writer. Open write one. Oops. Create chunk in data chunks. 0 sized chunks. Now, you want this as 24-bit, so write the address and size. Well, I could use get set functions for these, but data. Data docs to array. Address equals chunk. Base address. Oops, yes. And size, get data size. Now, Colin, are you wanting these in Intel format? So little endian or big endian when I write out the 24-bit values? I'm assuming the Z80 and Z8 are in little Indian format, so easy enough to change if I'm on. Ideal. That's the address. I could put switches in to allow you to flip it if you ever need to, but as is specifically for you, yeah. Can't see many other people are going to want it, but hey, if anyone does that's watching this, drop me a message. I'll add some command line switches, I don't mind. 24-bit size. Like the data, I guess. Right, chunk dot get data. Oh, actually, what I'll do is go byte array data equals chunk dot get data. Data dot count. It's not equal to size. We've got some serious problem if those two don't match. But you know, stranger things happen at sea. Let's print an error. Data mismatch. Size mismatch. Oh, not sure you've seen any of that. Oh well. This is one of the things I need to fix with this tool. What have you? No, you've been stuck on the old view. Oh. So yeah, so what I did, if anyone's watching this since it didn't seem to stream that bit, create a new binary writer, run through the chunks, make sure the data sign is 0. It's not 0, sorry. Pulled out the address and size. Still, I don't know why it's still upset by that. Oops. There we go. Write it in little Indian formats and write out the data chunk size. Pretty much all there is to it. I'm just going to run it and open the file so we can have a look at it in the binary editor. Right. So this is the binary file. 7A EO00 and it's writing 2000. 2000, yeah, let's see, is that right? Yeah, well, in theory, that's a crude. It doesn't handle all the Intel format. I might need to add some more. There is also types 2, 3, and 5 finds linear address and then there's segment addresses and things, but hopefully that's enough for what Colin needs. If not, I'll do another video another time and see if that fixes up any problems. But for now, hopefully I'll send it over to Colin and he can give it a whirl and see if it does what he needs. Right, I shall sign off. Again, as always, any questions, drop me emails. Just drop it to adrian@apbdeveloper.co.uk. Not just about this, anything really. Game dev. Been knocking around this industry for 25 years, so happy to answer any questions. Yeah, see you all later.